Hello, everyone. Let's go ahead and get on with a lecture on annuities. This lecture will be very similar to the lecture on compound interest, or at least how we'll sort of do these problems is they kind of look similar. So having that sort of idea of how you've worked out compound interest problems, having that idea in the back of your mind might be helpful here. Let's go ahead and actually talk about annuities and what they are. So, an annuity is an investment plan. So it's actually you saving money, and you, the investor, are going to make a regular payment into an account. And two things I want to mention here: we use this word payment, but and that could be confusing because generally when you hear payment, you think that you're giving up money, but the jargon that is used, the sort of way that us in the financial world will talk about annuities, when we say this payment into an annuity, that's talking about you putting money into your account. A better word might be a deposit. And so let's go ahead and actually say that paying into the annuity. This is a phrase that is used quite often. This is just equal to deposit, right? So it's like you're putting money into the bank, into the annuity, and we sort of speak of this annuity as though it's an actual entity, as though it's an actual thing. So we say like pay into the annuity, like I've said. So that's the first thing I want to mention. And the second thing I want to mention is that this account is a compound interest account. So we are really just doing compound interest here with this annuity. A couple things to note: the payment in the problems that we're going to be dealing with will be fixed. Most annuities are like this. Most of the time, when you have a payment into the annuity, it's going to be a fixed amount every month or every year or every day or every week or whatever the time frame is. But generally, that payment is fixed. It doesn't have to be though, but generally it is. The interest rate does not change. Again, it could, but most of the time it doesn't. And the problems that we'll be dealing with, it will not change. And then we've seen the phrase compounding rate before. We've given that a variable n. Let's go ahead and put n right there. That's going to be the same thing as the payment rate. And really all I mean by this bullet point is just saying, however often you pay into this annuity, however often you sort of deposit money into this, that's your payment rate, that's your compounding rate, that's the value of n. One thing to mention here with annuities is that generally they're pretty strict on you actually paying into this. A lot of times it's not really up to you as to when you want to deposit stuff. You're just expected to deposit, to pay into the annuity regularly at this payment rate, at this compounding rate, whether that be every week or every month or every 3 months or every year or so on. You could have a bunch of examples. So what I want to mention here is kind of what an annuity actually is doing. And I've mentioned that it is a compound interest account. So I'm just gonna write compound interest right up here, just so we keep that in the back of our mind and we just kind of are remembering about that, that we have compound interest going on. So let's just use an example. Let's say that I'm going to put in let's just say $100 every year. Let's keep things simple. So we're going to put $100 every year into the annuity, and let's sort of track what happens as we go through this timeline. So right off the bat, we start off at $0. We have nothing. We start with this annuity, and then we put $100 in. Yay, we've got $100 into our annuity, and now a whole year is going by, and during that year, we don't do anything. We don't bother putting any money in. We're just putting in $100 every year. And so we don't bother putting any money into this annuity. But over the course of that year, we actually will have interest that accrues on this. And so what I'm going to kind of sneak in here, let's just say that we have an interest rate R equals 10%. just to keep numbers simple right there. So we've got a 10% interest rate. That's great. So then over the course of this year, what happens is the $100 that we have, we end up adding 10% of that into the account, according to this sort of compound interest. And so we would end up adding 10% of 100 is $10. So we'd be at $110. And then what happens is we're going to, after the year is up, yes, we get our interest that I can highlight here, interest. So payment, interest, payment here is going to get us up to $210 because we're going to add $100 in. And then what's going to happen is we are going to have interest that accrues on that $210. And the interest that accrues there is going to be 10%. And so really what you could, we don't need to really keep going here, but we'll kind of keep seeing this sort of trend that goes on where we just keep adding in money and then adding in interest and then adding in money and recalculating the interest. And what happens here is because you're adding more and more money into this account, the interest that accrues on each one of these steps as we go down, it keeps increasing and it keeps getting bigger and bigger and bigger. And that's good because the interest that is accruing, because we're talking about an investment, that's helping you. It's giving you more money. And so the interest is going to get pretty large here, and it's actually going to help us a lot. We'll see some examples here of why, or sort of how much money you can actually get by doing this. So let's go ahead and look at how to actually calculate this amount. You could do this sort of step by step over and over, and every single time you want to do your interest calculation, you could go plug things into that compound interest formula that we've seen before. But that's going to be very ugly. There's a lot of steps here, and especially if I did something like we were dealing with this over 40 years, you're definitely not going to just do this over and over and over. So there, fortunately, is a nice simple formula that we can use, and it is right here. And maybe I misspoke there. Maybe it's not that simple. There's a lot of variables to plug in here, but the good thing is that we've actually seen all of these variables before. So we've got lowercase r as the interest rate, n is the compounding rate, that's how often we're paying into the annuity, t is time in years, and then this capital R, we've seen that once before. Just want to mention that that's our payment amount. We've used capital R as a monthly payment amount before. We'll use that letter again here to describe how much you're paying into the annuity every month or every week or every quarter or every half a year or every year or whatever it is. A is going to be that future value. That's just how much money you have at the end all be all. Yay, we've got it. So let's go ahead and work out an example here. And let's go actually copy this. Keep this in our back pocket to just move from slide to slide. All right, so we've got an example here. Let's find the future value as well as the interest earned. So we'll start with the future value, then we'll go to interest of an annuity where the payment is $275 quarterly. So that'll be 4 times per year, every 3 months. The interest rate is going to be 6.5%. And again, it's going to be compounded quarterly. For the problems that we're dealing with, the payment rate, how often you're paying in, and how often the interest is compounded, they'll be the same for our problems. They don't theoretically have to be, but for what we're doing, they will be. And then you're going to do this for 6 years. So basically what's happening is you're putting in $275 every 3 months, and you're doing that for 6 years. So sort of calling out to what we need to, what we better have in order to calculate this, we should have capital R, which is that payment amount, and that's going to be $275. And we are putting that $275 in 4 times per year. Again, that compounding rate, that payment rate is 4 times per year. So N would be 4. Lowercase r, don't get it confused with capital R, is 6.5%, which is 0.065. And then the time t is 6 for 6 years. So right there, we've got everything. We can just do a nice plug and chug into our formula. Just because we have a lot of sort of ugly numbers, I have actually typed this up already and I won't bother writing it out, but let's go ahead and just look at how we plug everything in here. So we start off, R is my 275. That's all good. We've got that outside of this big bracketed parentheses there. So we're going to have to do everything inside this parentheses first. And then even within this guy right here, we're going to have to deal with all of this first. So let's sort of hone in on this part right here, which is right there. I plug in my R of 0.065. I plug in my N as 4. I plug in my N and my T as 4 and 6. And on this step right here, what I'm actually going to do first is I'm going to deal with what is inside the parentheses. So I'm going to do 0.065 divided by 4. And that is going to give me 0.01625. I add 1 to it. I get my number. And I know I'm not writing all this out. We'll see this on the next slide. Basically, what I want to focus on is the order of operations here. So we're going to do this division first. And then I'm going to add 1, and then I've got my number right there, and that's good. So I have my number there, and just to show you, that's that number. So we've got that nice and simplified. Then I'm going to do my 4 times 6, which is 24, and what you can see there is now I have that number on the inside raised to the 24th, and I've simplified that part right there. So then carrying on also, don't forget we have this R over N. So I'm actually just going to do this division and just leave it on the denominator. So when I do my 0.065 divided by 4, I get my 0.01625. And this will be good. I can actually copy this over. Let's go ahead and do that. So we've got that right there, and just to sort of call out, just so we can see exactly what's going on, matching up. So I've got my 275, my 275. I've got my 0.065 over 4, and that 0.01625, those are the same. I've got this whole thing inside the parentheses. 1 plus 0.065 over 4, that's 1.01625. And then I've got my 4 times 6 is my 24. Now at this point, I can calculate this first, then subtract 1. When I calculate this, I am going to get 1.472357995. Then I subtract 1, and so this just becomes a 0. And so this whole thing in the brackets here, all of that right there is just this 0.472357995. You'll notice I keep a lot of decimals here. I like to do that because I am going to multiply it by 275 and then divide it by another number with a lot of decimals. And keeping all of these decimal places really helps me maintain an accurate answer here. If I were to cut this off at 0.47 and just leave it like that and ignore all of this, this number would just be very rounded and it wouldn't be that accurate. So I like to keep a lot of decimals here, just like in compound interest. At this point here, I can just do my multiplication and my division. There's nothing crazy there. And I get my $7,993.75. So order of operations there. Don't forget your PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. We've got all that. Then here's what I want to point out here. We found our future value. We've got about $8,000. And so the question now is, okay, well, that's fine and dandy. I've got $8,000 after the 6 years, but how much of it was interest and how much of it was just money that I actually put in? And we can calculate this very easily. So I put in $275 4 times per year, and I did that for 6 years. So if we actually just go ahead and we calculate amount of money, let's use the word deposited. So this is just how much you put in. This is going to be the $275 that you put in 4 times per year, and you did that for 6 years. So you put in $275, you did that 24 times, really. You did it 4 times a year for 6 years. And if you actually calculate this, you get $6,600. Let's make those sixes look a little better. And so right there, that's the amount of money that you deposited into this. But obviously we ended up with 8,000 roughly. And so a lot of it was interest. And we'll do that last calculation in a second. What I want to point out here is this guy right here. What I'm actually doing is I am taking capital R, I am multiplying it by N, and then I'm multiplying it by T. And so that amount of money that I've deposited, you could write it as just R multiplied by N multiplied by T. So if $6,600 of it is mine, right? That's the money that I put in, then we could sort of just do a very quick guess. I got to get up to 8,000 total. Well, so that means about 1,400 of it was interest. And to do that calculation exactly, we have our final value right here of about 8,000. I'm just rounding to make it sound quicker. We got about 8,000. We subtract off that N as being 4 times T is 6 times R is 275. That's that 6,600. So we just take that difference, and roughly $1,400 of this was interest. And we've done that calculation right there. We've just taken that final value, that future value, and we've subtracted off how much was paid into the annuity, which, as we saw on this past slide, was just R times N times T. You can flip the order of those, N, T, R, it doesn't matter what order because they're all multiplied. But there we go. We have a calculation for that interest. And that's really, that's it. That's our example right there. We've answered the questions of what's the future value and what's the interest earned. One last thing I want to mention here is actually a callback to this formula that we've seen over and over again. A equals I, let's say P plus I. Principal plus interest. So we've seen, obviously, that whatever your future value is, you can just break that down into, hey, it's the principal amount. It's how much you started with in this investment, how much you put in initially, and then you're going to add the interest that accrued that you got as a result of having that money in there in the first place. And what I want to do here is I actually want to rearrange this formula to solve for I. And if I do that, I'm going to end up with A minus P. And so what I'm noticing is I'm noticing this NTR part, that's the amount paid into the annuity. It kind of matches up with the P right there. If I'm looking at matching up these equations here, let's go ahead. Let's call out these. If I'm calling out these equations as sort of looking kind of identical, then I'm matching those up. That P looks like that NTR. And let's think about this. In these old compound interest and simple interest questions, we had a principal P, which in those cases was just an amount that was placed into the bank or into this investment in the very beginning. And now we're looking at this NTR. This is the value, the amount of money that was paid into the annuity, the amount of money deposited over the lifetime of the annuity. Obviously, it's not one lump sum of $6,600 in the very beginning, but over time, we are paying all of that $6,600 into the account. And so this right here is really just a fancy way of saying this is your money, and the interest is how much extra you got as sort of a thank you for investing. And then just like back here, the principal was how much money you put in the very beginning. And then the interest was that sort of, hey, thanks for investing. Here's some extra money and interest. And now you have your future value. So just kind of pointing out this right here. If you want to just sort of memorize this as a formula, you're welcome to. Again, as I've mentioned, I don't really recommend memorizing a lot of these formulas. It's kind of just some more intuitive thinking of, hey, if I want the interest, it's just the difference of how much I ended up with versus how much I put in myself. And that's your nice, simple way of calculating that. Because I could definitely throw questions at you where this formula might lead you astray. So just kind of try and think about these intuitively rather than formulaically. All right, that'll be it on the lecture. We've done our nice example there. And we'll go ahead and call it at that, and I'll leave you to the worksheet.